you're doing okay today. Let me know if you can hear everything okay. Looks like everything is working on my end, but I guess we'll see. I'm getting one small error in YouTube, so one of these days we'll figure all this out, but hopefully today is that day. All right, we're looking at JavaScript, or Eloquent JavaScript. We're on Chapter 6, The Secret Life of Objects, which just sounds like the secret life of pets to me, but here we are. Basically, objects, we're going to look at classes, how JavaScript is basically built off objects, which we've already talked about a little bit. I think I diverged from the book slightly here and there. So, but yeah, hopefully you can hear everything okay. Awesome. Thanks, Alexander. Appreciate it. Okay, let's go ahead and get started. I guess I will, first of all, if I can get everything working, here we go. Jump over. Hi, everyone, officially. Hope you're doing okay today. It's nice and early in the morning for me. So we're going to jump straight in to Eloquent JavaScript. And I've got it pulled up over this way. So here we are, The Secret Life of Objects as promised. So cool. All right, let's jump straight in. And I don't know if we're going to get to this whole chapter because there's quite a bit in it. Conceptually, I did look through some of it, not all of it, but let's go ahead and start with the conclusion, the summary, so we kind of have a sense of where we're going. So if you're just joining us, we've been working our way through Eloquent JavaScript. This is this book about JavaScript, and so we're working through it. And our goal is to get a better grasp of the fundamentals of JavaScript. So we're kind of going through it together, and I'll break from the book and talk about it some. So I've done, 5 or 6 streams so far on it. I think there's like 21 chapters or something, so we've got some time to go. I'll probably take a break at some point, go back to just like coding on live stream, and then jump back into this. But right now, we're looking at the secret life of objects, and it says objects do more than just hold their own properties. They have prototypes, which are other objects. They act as if they have properties. They'll act as if they have properties they don't have as long as their prototype has that property. So we'll talk about that. Basically, you inherit properties from higher up. Simple objects have object.prototype as their prototype. Constructors, which are functions whose name usually start with a capital letter, can be used with the new operator to create new objects. The new object's prototype will be the object found in the prototype property of the constructor. If all that's gobbledygook, hopefully by the time we're done, that'll make sense. You can make good use of this by putting the properties that all values of a given type share in their prototype. There's a class notation that provides a clear way to define a constructor and its prototype. Basically, what we're going to find is that you can kind of keep each function, each property you're getting as separate items, or you can group them all together into an object and kind of package them up so that if someone wants to look at like a student, for instance, in your classroom, they would have everything they need to interact with that student on like their own little instance. So it groups items together like functions and properties about that person into one kind of overall item that you can then create new instances of. So I can have a student that's like the kind of the mama student, the idea of a student, but I can assign and say, okay, I'm going to create a student named Chris. Well, now I've got a student named Chris and they have the grade, they have a way to fetch their email, they have, all that stuff attached to their instance. And I can create another student named whatever, so that's the idea of what a class does, what this object-oriented programming is. All right, you can define getters and setters to secretly call methods every time an object's property is assessed or accessed. Static methods are methods stored in a class's constructor rather than its prototype. The instance of operator can give an object and a constructor, given an object and a constructor, tell you whether that object is an instance of that constructor. One useful thing to do with objects is to specify an interface for them and tell everyone that they are supposed to talk to your object only through that interface. The rest of the details that make up your object are now encapsulated behind that interface. You can even use private properties to hide part of the object you want to hide from the outside world. Again, we'll talk about this, but basically we're talking about classes and object-oriented programming. More than one type may implement the same interface. Code written to use an interface automatically knows how to work with any number of different objects that provide the interface. This is called polymorphism. Not sure I've heard that term before. We'll figure it out. When implementing multiple classes that differ in only some details, it can be helpful to write the new classes as subclasses of an existing class, inheriting parts of its behavior. In other words, maybe you have a student, but you have another type of student that's like a student, like a teacher's assistant that's also a student. Well, you don't have to redefine everything about that student. Instead, what you can do is have like, oh, they're the student, but they also have these extra things on top. That's the idea here. Okay, so hopefully that gives you a sense of where we're going. And if that's confusing, then perfect, because that's what we're going to do is try to clean this up. Okay, awesome. Thanks, Alexander. Appreciate it. All right, let's see. Chapter 4 introduced JavaScript objects as containers. I'll probably read most of this beginning section because there's a lot of the details here. I'll want to jump into it. So just as a heads up, I don't always read them like straight, but I think I will today. In programming culture, object-oriented programming is a set of techniques that use objects as the central principle of program organization. Now, I will just mention that like it used to be that this is kind of the way you wrote, for instance, React is more in an object-oriented style. And now you don't really. People are much more into functional programming in JavaScript, the JavaScript world at least, but a lot of languages are mostly object-oriented based. So it's still important to know, and you'll run across this a lot, especially in libraries or things like that. So you need to know basic ideas of object-oriented programming. Though no one really agrees on its precise definition, object-oriented programming has shaped the design of many programming languages. Hey, how about that? Including JavaScript. The chapter describes the way these ideas can be applied in JavaScript. All right, the main idea in object-oriented programming is to use objects rather than types of objects as the unit program organization. So again, it's a way to organize data about whatever your program is under kind of one subheading and group things together. Setting up a program as a number of strictly separated object types provides a way to think about its structure and thus enforce some kind of discipline, preventing everything from being entangled. Now, JavaScript is kind of known for not having any discipline, so I think that's probably why. It's not like object-oriented programming isn't like the main thing that people think about today with JavaScript, but it does help with a lot of like mental models and the way you think through your code. The way to do this is to think of objects somewhat like you'd think of an electric mixer or other consumer appliance. People who design and assemble a mixer have to do specialized work requiring material science and understanding of electricity. I'll zoom in a bit. They cover all that up in a smooth plastic shell so that the people who only want to mix a pancake batter don't have to worry about all that. They have to understand only a few of the knobs that the mixer can operate with. And that's kind of the idea. There's a lot of stuff that goes into your program that you may not want to like expose to the user. You just want them to be able to hit like a function that says, start mixer, and you'll handle all the rest. And so you can kind of package that up together to make it easier to work with. So this is one of the reasons you still see this a lot in libraries. It's because it allows for that. Now, you don't have to do object-oriented programming for libraries, but that's one of the reasons you'll see it. Similarly, an abstract data type or object class is a subprogram that may contain arbitrarily complicated code, but exposes a limited set of methods and properties that people working with it are supposed to use. This allows large programs to be built up out of a number of appliance types, limiting the degree to which these different parts are entangled by requiring them to only interact with each other in specific ways. So not only can you send along specialty tools, you can also define how they interact. And so again, it just gives you as essentially like a library author, even if it's your own little library, your own little section of your code, it gives you a lot of control over what you expose outside of that little class, how those things interact with each other. So it gives you control to kind of set the mental patterns for working with data and functions and stuff like that. If a problem is found in one such object class, it can often be repaired or even completely rewritten without impacting the rest of the program. Even better, it may be possible to use object classes in multiple different programs, avoiding the need to recreate their functionality from scratch. You can think of JavaScript's built-in data structures, such as arrays and strings, as such reusable abstract data types. All right, we're going to get into some details of what this means in a second, but for now, just stick with me for the last couple of paragraphs here. Each abstract data type has an interface, the collection of operations that external code can perform on it. Any details beyond that interface are encapsulated, treated as internal to the type, and of no concern to the rest of the program. We talked about this in the summary just a moment ago, but we'll talk about encapsulation in a moment here. Even basic things like numbers can be thought of as an abstract data type whose interface allows us to add them, multiply them, compare them, and so on. In fact, the fixation on single objects as the main unit of organization in classical object-oriented programming is somewhat unfortunate, since useful pieces of functionality often involve a group of different object classes working together. So here they just cut across some of the stuff I've said, which is like, single objects. Not only can you like package stuff up together, but you can also like connect those with other groups of objects. So that's all they're saying. Okay, hopefully that at least gives you a sense of where we're going, like the mental idea of like organizing code around like a certain topic. And if you know that much, you know enough to get started here. Okay, methods, let's talk about this. In JavaScript, methods are nothing more than properties that hold function values. So we've actually seen this before. We've talked about methods. It's just another name of functions essentially, but based off of like how they're structured. So for instance, let's just jump over here. I think you can see that, yeah. So we're gonna run, if I can think, Quokka on this. So for instance, I'll have a string. So I could say like name equals hi. Oh, I forgot this is real high. We don't need this. Okay. Name equals Chris, something like that. I can come in here and say name dot, and I have a bunch of things on this. So I could say like to uppercase like this, and it will uppercase this, right? And I guess to see this, oops, I would need to console log this if I can make it work. Come on. My shortcut's not working. All right, console.log, name.to uppercase like that. There we go. Okay, so it's showing to uppercase. Now this right here is a method. It takes in whatever I pass to it, in this case, the string name, and it uppercases it. So this we call a method because it lives on the object of a string. And again, we've talked a little bit about this so far, but everything in JavaScript in the end is kind of an object. And so this string here is an object as well, even though I've just got it declared like this because JavaScript attaches a bunch of methods to it and properties and things like that. So for instance, I could come in here and say the length. Now this is not a method, it's just simply a property. And so I don't have to call it. I don't have to do the parentheses afterwards. It just tells me the length of my string right here. Where did this thing come from? Well, this is attached to the prototype, which is what we're going to look at today. So JavaScript at its core has these fundamental principles to it of object-oriented programming. All right. Hey, Fuzzy, welcome. Good. I need someone to help me early in the morning. It's late in the afternoon for you, so if I mess up, I expect some help. All right. And JavaScript methods are nothing more than properties that hold function values. All right. So for instance, this is now taking this to a new level. We just talked about how things live on objects. Now they got two objects here, white rabbit and hungry rabbit. So you've got a type and we've got speak. So this speak right here is just saying that this function is basically part of this object. Does that make sense? So they're actually saying like, technically you could say like speak equals speak, but they're shortening it here. They're just saying that I now on this white rabbit and on this hungry rabbit, I have both a type and I also have speak. But speak doesn't reference a property. It doesn't hold like a single value. It holds a function. And this is the function it holds. Okay. So here, what we can do is take the object, white rabbit, and we can use the same kind of notation like we did with to uppercase or whatever the other one is. I just used length. Length would be like grabbing the type. So I could come in here. And maybe let's comment this out for now just so I control what we kind of talk about here, but we can have white rabbit. Dot, and I could say type, for instance, and if I play this, I guess I probably have to console log this like that. It should give me back white. So it's giving me just the item here. Now this is just a single value, so it's passing this back to me. But if I use a function here, this function is going to take, now we haven't talked about this yet, we'll talk about this in a second. It'll take this dot type, which would be whatever its object is. You kind of get this magical word called this that passes along that references the actual object it's found within. So what it's saying is this.type, rabbit says, and then whatever line you want them to say. The line is, oh, here, yeah, whatever you pass it. All right, hopefully that makes sense. So now if I comment this out, it's going to use this function speak with white rabbit, and it's going to pass in just one thing because that's the only thing the function needs, which is a line. And it gets this from the actual object. So when you call this function, this method on an object, you also get access to everything within the object. There are some ways to limit that, but that's the default here. So the white rabbit says, oh, my fur, my whiskers, whatever. We got any carrots, same kind of thing. And notice that this one knows it's hungry rabbit, again, because it's got access to this inside of here, okay? So this keyword is a way for us to basically access stuff within the parent object. So So typically a method needs to do something with the object on which it was called. When a function is called on a method, looked up as a property and immediately called as an object.method, the binding called this is in its body automatically and points to the object on which it was called. So let's come over here. Let's say we have, I don't know, like person, all right, whatever. And this is going to be an object. It's going to have a bunch of different things on it. So I could have age is 24, name is Chris, favorite food, I don't know. We'll say like crepes. I don't know how to do the fancy French carrot thing. I'm sorry, I'm American. What else? We just say like, oh, we need a function. Yeah, so we could say like get, I don't even know what to say here. Let's say like get capitalized name. Sure, that works. And so we could write this either outside the function. This is what they did in that example. Or we could also write it inside the function. Doesn't really matter. So for instance, this could be a function expression if I say function correctly. So this could be a function declaration here. And we could just say like return this dot name dot to uppercase. And notice it can tell it's a string. Now this right here, this scope is talking about the object itself, the outer object. So this is why when I say this dot, I suddenly get access to all the different items, favorite food, cap name, so I even get access to itself as well. So now what we can do, this dot name dot to uppercase. Obviously, this is not a super helpful method here, but it is a method. It's a function that lives on here, this declaration inside of an object. So now for this person, I can just console.log, and I can take the person dot, and notice I've got all this stuff available. Now, I didn't say I had to pass anything into this function. In fact, it doesn't take anything. So all I have to do is call it, and when I invoke it and save it, you'll see I get back Chris. Well, how does it know what we're talking about, what the name is? Well, again, it uses this. This is confusing. There are times in the past where you would say like this equals that, and then you would use that, but we don't have to do that anymore for a bunch of different reasons. But you can see it has access to this, which is the object itself right here. Now, this is different, no pun intended, when we look at arrow functions, which I'm assuming they'll get into here shortly. You can think of this as an extra parameter that is passed to the function in a different way than regular parameters. If you want to provide it explicitly, you can use the function's call method, which takes this value as its first argument and treats further arguments as normal parameters. So here they're saying you could call speak.call and you pass it white rabbit. It's not normal. I don't see people do this a lot. I think I knew you could do this, but it's been a long time. So again, if we came over here, instead of saying person.get cap name, whatever, we could say .call, and then we could pass in the object of person, right? Speak. Oh yeah, you have to pull in speak, which is, in this case, we couldn't really do this because it's inside, like it's declared inside here. But in this case, they have the function declared outside. So they're saying you can call it, pass in as the first item, the actual object, and then pass and speak. But because ours is defined inside of the object, I don't think there's a way to do that. Anyhow, like I said, it's not super common. All right, since each function has its own this binding, whose value depends on the way it's called, you cannot refer to this of the wrapping scope in a regular function defined with the function keyword. Arrow functions are different. They do not bind, so we'll talk about this in a second, but it kind of only makes sense within the arrow functions if this didn't make sense. They do not bind their own this, but can see this binding of the scope around them. Thus, you can do something like the following code, which references this from inside a local function. Okay, so here we have find. This is returns some, whatever this value. So here you'll see that I've got it this inner functional or arrow function inside here, right? And this dot value can reference the actual value outside here, right? Does that make sense? All right, so let's run this here. All right, so we're saying find 4 and 5. What am I trying to find here? Find in the array some value where the value equals the value. All right, does the value exist? Okay, that makes sense. So this dot value, it basically can reference outside of its own parent scope. You cannot do that with a functional value. Yeah, this self, nice. Yeah, this equals self. Yeah, that's a good way to think about it. A property like find array is an object expression, a shorthand way of defining a method. That's this right here. This object, this arrow function right here. Let me make sure I'm understanding what it's saying. It creates a property called find, gives it a function as its value. Oh, this function expression. It's the same thing as saying, like, I think basically is const. Yeah, well, because we're defined inside of an object. We're not using the function keyword. It's a function expression. An object expression is a short way of defining a method. So it's a short way of writing a function within a method. Usually I use the function keyword if I'm doing this, but this also works. Like, you can do this shorthand. It's the same thing as saying find equals function like this. Or not equals, because it's an object. So it's the same way as doing this. It's just shorter. So let me run this again. Still true. Okay. But instead of having to write that, there's a shortened way, which is you just write it directly here, but you reference it by that name, which is why we have finder.find. Hopefully that makes sense. All right. If I'd written the argument to some using the function keyword, this wouldn't work. So this right here, this function, if I wrote this, so instead of sum like this would be what function? We take in an item, right? And then I want to return if the I is equal to, I forget what our even, yeah, no, that works. Somehow I tabbed, sorry. Classes, where are we at? Finder, okay, here we go. If, let's see, return I equals, I think they just did like that, this dot value. Now I don't have access. This dot value is only going to be inside this block, I think. So if I come in here, I'll say false. I think I did that correctly. The syntax, you don't usually do these. You usually do arrow functions inside of here for sums. So, so basically the function declaration, function expressions, all of those act differently than arrow functions. Arrow functions in part were created so that you didn't have to worry, like you could access this outside of the current scope. All right, it's a very dirty way of doing methods. Ideally, methods should be attached to classes, never inlined. Yeah, so you can read, which is coming up next. That's right. Man, Fuzzy, previewing everything for me. Thank you. It's always hard when I do these streams because it's literally like 10 minutes after I wake up. So it takes me like half the stream just to wake my brain up, but I don't really have time during the day. So this is what you get. You get early morning brain, Chris. So thanks to Fuzzy. A property like find array is an object expression. We already looked at that. Okay, we looked at all that. Okay, prototypes. So one way to create a rabbit object type with a speak method would be to create a helper function that has a rabbit type as its parameter and returns an object holding that as its type property and our speak function in its speak property. We'll look at this in a second if that doesn't make sense. All rabbits share the same method, especially for types with many methods. It would be nice if there was a way to keep the types methods in a single place rather than adding them to each object individually. So you see how we can basically define them outside and then use them within using this idea of prototypes. Prototypes are ways to do that. Objects can be linked to other objects to magically get all the properties that the other object has. So you can kind of combine these tool sets. Plain old objects created with the just bracketed notation are linked to an object called object.prototype. So even though this has nothing in it, I can do empty dot toString. This happens to be named empty. It could be named anything. Nice, Fuzzy. And you can also turn it to string, which in this case, here you see we just get back function because we didn't call it. We could call it like this, which wouldn't help us at all. All right, it's just going to give us object, which is what they show down here. But when we play it this first time, you'll see that we get back a function. This tells us that this is a function that lives on this empty object. Now, how this happens is that every time you create an object in JavaScript, it automatically gives it all the superpowers of kind of this mama object array that holds all these special properties to it. It looks like we just pulled property out of an empty object, all right, toString. But in fact, toString is a method stored in object.prototype, meaning it is available on most objects, basically all objects. When an object gets a request for a prototype that doesn't have its prototype, we searched for the property. If that doesn't have it, the prototype's prototype is searched. So it keeps going up kind of the list. We'll look at an example here, I think, in a second that will help. And so on until the object without prototype is reached. Object.prototype is such an object. All right, so we can get prototype of an empty object, and this tells us it's object.prototype. Here we can object.get object of object.prototype, and there is nothing. So once you reach the kind of the mama object, you're done. There's nothing else to go up to. Let's see, are they going to give you an example of this? If not, maybe I should jump over and do this. All right, so let's come over here. We've got this object here. You'll see I've got things like age, right? I've got favorite food. I've got get name, cap name, got name. All those are things I defined, but I also have things like string. Technically, I have here as well. And if I do this, it'll say object. Where did this thing come from? Well, what they're saying is there's something called the object prototype. So every object that's defined also inherits a bunch of stuff. So we can actually kind of show this as well, but probably the easiest way to do this is to grab this and let's just jump over here. And let me show it in Chrome DevTools if I can. Hopefully you can see this okay. Zoom in a bunch. Oh boy, not that much. Okay. So we'll have this here. And if we do person dot, notice I've got all the things we just expected, but I also have this prototype. Has on is prototype of all this extra stuff as well. But if I look at this prototype, let's see what it'll give me. Yeah, here we go. So here I've got the constructor, has property, is prototype of, to locale string, string of, definer, get proto. So here we have length, arguments, color. All this stuff is attached to the actual object itself. And I should be able to say, can I do this? No. I forget how I even access that. So all they're saying is like, is this a prototype of object.prototype? And it's, prototype. If I can. I think that should work. It's not, but then if I do the object of itself, it is. So all these things are attached to it automatically, right? Object is, oh man, there's two words that trigger me. Yeah, seriously. You see that a lot sometimes if you're in JavaScript as you continue to do stuff. So in other words, every object gets all these things added to it. Now the same thing goes for other details. So for instance, if I say like name equals Chris, this right here, this string, so name dot, I have all this stuff as well. At, big, blank, bold, char, all this stuff. This stuff is added by the prototype itself. So this prototype itself is attached to all of this by default. Same thing with numbers, same thing. So in other words, there are these objects within JavaScript, and the way they would look is something like this. So I'd have like an object that's called object, all right? And it would have all this stuff attached to it. So it would have things like toString method, and this toString method, would be a function that does this thing to a string. Like, does that make sense? So when you create an object, this object is basically merged with whatever objects you create to give you extra methods or properties or things like that. So for instance, we could have like a length property on here, which is what it has. And it would simply say this dot, and then it could basically count the string. Now, how you do that, you'd have a function here that then took in this. I guess you wouldn't have to take in this because you'd have it there, but you'd probably take like whatever the item is you'd pass in. I guess this is just the object. So you could say like this dot, and then it would return to you the length of that object. And so whenever you call the length, it's just going to give you back the value because this is going to return whatever the length is to you. And this object is basically going to be merged with my person every time automatically by JavaScript, like the language itself. And so you get access to a lot of things just by default of writing objects because everything is an object in the end in JavaScript. Hopefully that makes sense, all right? Many objects don't directly have object.prototype as their prototype, but instead have another function, another object that provides a different set of default properties. Functions derive from function.prototype, and arrays derive from array.prototype. So you can see here, like this math.max function, it comes from array.prototype, not object.prototype. But the idea is prototypes live on everything. Such a prototype object will itself have a prototype, often object.prototype, so that it still inadvertently provides methods like toString. So here, this math.max comes from array.prototype, but the wrapper around array.prototype is object.prototype. So you get everything in array.prototype. If it can't find whatever you're looking to do in array.prototype, it looks up to the object.prototype. If it can't find anything there, then you just don't have the method available. So in other words, there's kind of this scoping that happens where your individual class you've written down here has its methods that you've defined. Outside of that, if it happens to be part of, like in this case, we're using math.max, which comes from array.prototype, that means it has all of the array prototypes to it. And then wrapped around that is the object.prototype as well. Hopefully that makes sense. Let me know if it doesn't. In the end, basically everything's an object. It's turtles all the way down. All right. Such a prototype object will itself have a prototype, often object of prototype. We just looked at that. Okay, so you can use object.create to create an object with a specific prototype. So we have here proto rabbit. Nice. It has a function called speak. And we have black rabbit where we say object.create proto rabbit. Now, what this means is I can like add extra stuff to it. Like, oh, let's add a type to it. Its type is now black. But if I can just use this speak immediately, because I've used object.create, it basically attaches this to it. So hopefully that makes sense. I can come over here. As an example, we can say like, I don't know, mega person. All right. This person right here, we want them to have additional items on top of them. So we can say object.create, and we're going to pass in the person. Am I doing this right? I think so. You don't do this a ton. So yeah. So I'm going to pass in the person. Now, what this means is the mega person suddenly has access to like age and that kind of stuff. The functions are the things that really kind of matter here. So get cap name. I can pass in just like this. Oops. And it says Chris. Well, where did mega person get Chris? It doesn't have Chris. It's literally nothing. It's just a declaration that says, hey, create an object based off this. Well, basically what it means is it inherits all these items here. So I could come in here and just say name as well, and it should give me back Chris. So it attaches all these things to it. So in other words, this makes a lot of sense when you're trying to like do more complex stuff. You don't want to have to redefine all these. So maybe you have this one section that's kind of like every single person has this, every single student has this, every single whatever has this, and you can wrap all these together, but kind of have them all defined in one place. And if you want to change it, you change it in one place and it affects everywhere else that that has been created. That's essentially what happens. Now, just like you can come in here and say like, let's take person dot, and let's create a new thing. We'll do like likes blue equals true. All right. Now, when I do this, you'll remember from our object lesson that it actually adds it to this object right here. So if I came in here and just did mega person, show me what's in here, and I hover over this, you'll see that suddenly this person likes blue. The person likes blue, which means now this mega person that's generated off of that also inherits that. So this inheritance can be really helpful, but it can be confusing if you're like, where did this thing come from? So that's what they did earlier, but they did it with the mega person. Mega person likes blue, but I just wanted to show you that it also works by changing the actual object that the thing is created upon. Okay. All right, let me make sure I got everything. This is called prototypical, I can't read because I have this thing kind of darkened today. Prototypical inheritance. Yep, it's one of the need to know, but you shouldn't be abusing old JavaScript security issues. Yeah, also true. That we have weird things basically in JavaScript because people said like, oh, I'm just going to attach this or use this method that I'm going to call. And so now suddenly like, what's the classic one? I'm not remembering right now. I'm sure Fuzzy can think about it. Let's see if I can make this visible because I can't see what he's saying. All right. But yeah, I can't think of the one I'm thinking of. But basically there was a library that used... Oh, what is it? It's going to kill me. Anyhow, there's a library that used a method that now we can't really use on the prototype because it confuses. Everything has to be backwards compatible. But so typically, you're not like you should never touch the prototype of core objects. Like you should never come into the object prototype because I could come over here and just say like, I'm going to take like the mama object. I think this is how you do it. like object dot, and I'm just going to create like a pizza method. And this is just going to be, we'll make it an arrow function that says like console.log, like pizza is good. Okay, so I could come in here now and let's just take the person dot, and now I have pizza on here. And if I call this, oops, pizza.person.pizza. Oh, it's because you'd have to do this in the browser, I think. But basically, you can attach things to the actual prototype. Or maybe it's like prototype.pizza. I think that's it, maybe. I don't know. I'm doing this wrong. But basically, you shouldn't do this. So I should know how to do this. But you can, on the prototype itself, you can basically attach new items. And so here, I'm basically attaching this. There's a way to do it. I forget. Yeah, jQuery does a lot of prototype injection. That's what it is. And so, but the one I'm thinking of, I can't think of. So anyhow, it's not important. Oh no. Where did I go? Okay. A proto rabbit acts as a container for the properties shared by all rabbits. An individual rabbit object, like a black rabbit, contains properties that applies only to itself. So like over here, if I said mega person, we created the person. Let's get rid of that. Like that. And let's come back here to mega person. All right. And what I want to do is do like is cool. All right. So right now this doesn't exist. And if I save it like that, it'll say undefined. But I could say mega person dot is cool and set this equal to false. All right. So they'll be false. If I try this with person itself, so it's kind of the object that it's created off of, what do you think will happen? All right, put in your bets now. It could be true, could be false, could be undefined, null, I guess, if you think, but you'd be wrong. It's undefined because this doesn't exist on the actual like object that it was originally created off of. So megaperson is created off of this, but it can have its own stuff as well. And that's what we've done here. All right, back over this way. I gotta zoom this out a touch. Okay. On the window object, which is big no-no. Yeah, seriously. Global this for applying methods to global scope. Yeah. Oh, I need to do the underscore proto on that fuzzy. I can't remember. Again, you shouldn't be doing it, so I'm glad I don't remember. A JavaScript prototype system can be interpreted as somewhat free-form, take on abstract data classes, types or classes. A class defines the shape of a type of object, what methods and properties it has. Such an object is called an instance of the class. And I think this was only added in like 2015. The idea here is like they were like, okay, people are using JavaScript for object-oriented programming, and they're kind of there's a lot of freedom in JavaScript. So let's create like a interface for working with this. That's what we're doing here with the class. So it's just a wrapper, basically a way to prettify a lot of it. So prototypes are useful for defining properties for which all instances of a class share the same value. Properties that differ per instance, such as our rabbits type property, need to be stored directly in the objects themselves. To create an instance of a class, you have to make an object that derives from the proper prototype, but you also have to make sure it itself has the properties that instances of the class are supposed to have. We'll look at this in a second if that doesn't make sense. This is what a constructor function does. So here we're saying make rabbit type, let the rabbit type. Okay, that's probably not how you'd really do it, but that's fine because you'd use the class method. This is basically the same as this. All right, so JavaScript's class notation makes it easier to define this type of function. So you might have a proto rabbit like the one we had up above. And if you want to make a rabbit, you have a function that you create called makeRabbit. People don't do this because of classes now, where you say object.create, and then you pass in the proto rabbit that's everything's based on, and then you can add extra stuff, and then you return the actual rabbit itself. That's all we're doing with this class syntax. Now, to clean this up a little bit, we can have a class called rabbit, and it takes a constructor, and this basically creates the thing, and then whatever type we pass and whatever we pass in here, we can define specially just for this instance of the rabbit. And then we can attach anything that goes more globally onto the rabbit itself at the outer scope, outside the constructor. I'll try to do an example here that makes sense. Class keywords start as class declarations. which allows us to define a constructor and a set of methods together. So here's the method that should belong on all rabbits, but for each individual rabbit, I'm going to pass on a type, and they'll have their own special type. So it allows you to basically get kind of the global stuff you need, but also specify stuff for an individual instance of something. Class keyword, okay, any number of methods may be written inside the declarations braces. This code has an effect of defining a binding called rabbit, which holds a function that runs the code in the constructor and has the prototype property that holds speak method. So this is going to reference the individual rabbit that I create. So whatever type I pass in, this will be customized. This function that lives on all rabbits, it will be customized for that particular rabbit. The function cannot be called like a normal function. Constructors in JavaScript are called by putting the keyword new in front of them. Doing so creates a fresh instance object whose prototype is the object from the function's prototype property, and then runs the function with this bound to the new object. And finally, it returns the object. Okay, so what we're saying is new.rabbit, and we just pass in killer. Why are we passing in killer? Well, that's our constructor takes one thing, right? And the thing it takes is whatever type the rabbit is. So it's the same thing as we did right here. We could write a function that says make rabbit, where we pass in a type. Then we use object.create, where we say, hey, take everything that's on a base object, wherever that one was, right here, proto rabbit. Take all this and assign it to whatever this new rabbit is. But also take the type I passed in and add the type to it, and then pass me back the rabbit. So class is just doing that, and it uses this constructor function to kind of generate that. So the nice thing is to actually interface with a class, all you have to do is pass new, whatever the name of the class is, which is typically uppercase. I don't think it has to be, but that's convention for sure. And then whatever I'm supposed to pass into it. And now I get back a killer rabbit that not only has the type of killer, but can also speak. It has the speak on it as well, that function that is on all mama rabbits. You know, everything that's connected to this kind of mama rabbit class, if that makes sense. All right. In fact, class was only introduced in 2015. Hey, I was right. Addition of JavaScript. I thought it was around there. Any function can be used as a constructor, and before 2015, the way to define a class was to write a regular function, which I would not have known, manipulate its prototype property. Oh, weird. Huh. Okay, well, I'm glad we don't have that anymore. I've never seen that. I mean, I'm sure I have in like library code, but it's not. So you take the prototype dot, and then you add a function to it. Huh. Nice. All right, for this reason, all non-arrow functions start with a prototype property holding an empty object. By convention, the names of constructors are capitalized so that they can be easily distinguished from other functions. So it's just convention, but it is the way they're written. It's important to understand the distinction between the way a prototype is associated with a constructor, though it's a prototype property, and the way objects have a prototype, which can be found in object.get prototype of. I don't know that we need to go over this right now, but I think let's just trust the book, I guess. It's important to understand the distinction between the way a prototype is associated with a constructor through its prototype property and the way that functions have a prototype. Okay, I think I understand what they're saying. The actual prototype of a constructor is function. Prototype, since constructors are functions, the constructor function's prototype property holds the prototype used for instances created through. Okay, so they're just saying like to figure out what type your rabbit is, it's always going to pass back function. But if you then object.get prototype of killer rabbit should be equal to the rabbit.prototype. Okay. I don't think that's super important to know right now. Constructors will typically add some per instance properties to this. It's also possible to declare properties directly in the class declaration. Unlike methods, such properties are added to instance objects and not the prototype. So here you see we've got this mama class called particle, and we've got a property on it called speed. This is outside of the actual constructor. So they're added per instance properties is okay. Like a function, class can be used in statements and in expressions. When used as an expression, it doesn't define a binding, but just produces the constructor as a value. You are allowed to omit the class name in a class expression. So new class has a function getWord where it returns hello, object.getWord. I thought this was like a refined keyword. I guess it has to be uppercase to be reserved. Anyhow, but you can just do new class and then basically immediately construct it if you want to. But this is not how people do it. All right, so let's before we jump into private properties, and maybe actually I might even just take a break. This is fairly new in JavaScript, which is great. But let's come over here first. And right now I've got this as an object, right? And we created a new one off of it like this. But every time I want to create one, let's say that I say like, well, every single time I create let's call this a student instead. And a student here, student 1, all right? Let's say every time I create a student, I want to add all these things, but I want them to be customized for the student. The only thing I really want is this get cap name. All the rest of this I want to be customized. Well, I could come in here and say we've got student, oops, like this, and I could grab this student name, and I could take the student, and then I could just say like, give me their age. Now they're 24, so I can come in here and say student1.age, and now it's going to be equal to 25. And now it changes it to 25 for this particular one. So if I have another one, like here, we take student2, and we take student2 age. Student2 age will still be the original 24. So I could actually start and just say like, I'm going to start with this as a default. And then for each student, or maybe I just have this undefined. Undefined for them. Let's do the same thing, undefined, and then undefined. Okay, so for all these, I undefined. This one I happen to assign a value, so it's now 25. But this gets really messy, right? You create a student, then you have to update all the things you want to be updated. What if we could just say, hey, let's create a prototype, a student here. We're going to do this kind of capital thing. We're going to pass in a constructor. So constructor. And this constructor itself is going to be a function. Now, if we look at the original example over this way, let's see. There was a way to view the JS objects via prototype, but for the life of me, I can't find it. Yeah, I think you do it like with the console.dir maybe or something. But you see, what we did over here is we took in a position and we assigned this dot position. So we're saying for this instance of the particle, you're going to make it equal to the position itself. Oh yeah, MDN has a better way of explaining it. Okay, well maybe we'll take a look at that in a second. So we're going to do the same exact thing here, where we have a constructor function, which we can call whatever we want, but they're using the shorthand. You could also do constructor, and then you could do this is a function, or, you know, whatever, if you wanted to, but usually it's just done like this. All right, so I guess we should do the same thing. So, and I was doing an arrow function or something random. All right, so this constructor function, we're going to take in a few things. We're going to take in an age, a favorite food, I don't remember what else, and like is cool, I don't know, is current student. Okay, so it's going to take in these three things, and then it's just going to set all these. This dot age equals to whatever the age is that was passed in. This dot favorite food is equal to whatever the favorite food is that was passed in. This dot is current student is going to be equal to whatever the is current student is that was passed in. So now we've basically defined all these things in the constructor. So I can, instead of doing this and then updating all the individual values, the variables values here, I can simply say new student like this, capital S, because that's what I've named it. And then inside here, I'm going to pass in all of these things I need. So we could say this new student has an age of 25 and a favorite food of pizza and true. All right, they are a student. Is not a constructor. What am I doing wrong here? Oh, I didn't name it a class. So now it's a class. All right. Like this. And this. And let's see, I can just do get cap name like that. And like that. Okay. There we go. So now I can pass this in as a class instead of an object itself. So this is the syntax where you have a constructor. That's why it wasn't liking my autocomplete earlier. So let's take this student, and you'll notice if I try to figure out, console.log the student1 dot age, this, and I save it, I get 25 because this is what I initialized, instantiated the object or the class with. But this student lives on its own. It's its own little item. It has the age 25, favorite pizza, a thing is pizza, and then true. But every student is going to have a get cap name because it lives outside the constructor. Hopefully that helps a little bit. Let's see. Forgot about that trick. I'm not sure which one you mean. We are now chapping on the door of object-oriented programming troops. Yeah. All right. Like function class can be used in both statement and expressions. We already looked at that. Okay. Maybe, let's see. Can we look at private properties, overriding derived properties? Maybe let's look at these briefly because I think we talked about them. And we'll stop at maps. That's a good place to stop. We'll have to come back next week because I got to get to work, but a little early. But yeah, private properties. It's common for classes to define some properties and methods for internal use that are not part of their interface. These are called private properties as opposed to public ones, which are part of the object's external interface. To declare a private property, put a hash sign, a octothorpe, whatever you want to call it, pound sign in front of its name. Such methods can be called only from inside the class declaration that defines them. So here I have this secret thing, and the only way I can get access to this is outside. So I could grab this right here. Well, let's see. Yeah, let me just add this over here. So we've got this get secret, i.e. all the plums. Oh, excellent. And if I try to come over here and I try to call get secret, you notice that like it doesn't exist. It's just going to say this isn't a thing. So in other words, you can't access it outside. However, I could say that over here, this is going to console log get secret. It'll be this dot get secret, I guess. Yeah. And notice I call it with this sign as well. So here, now if I use get cap name and I run this, is it defined to uppercase? Oh, it's because it doesn't have a name. Get out of here. Nobody cares. All right. So now, get secret. I ate all the plums. It console logs it up here. You can see that this way. It's not returning anything. So I guess I need to return like this and then not console log this maybe. Anyhow, basically it can pass the results of this function to me. I'm just console logging, so I'm not passing anything here. But this log itself, actually, let's just do it for real. All right, so like that, and then now I'm going to console log this here. Okay, so now it passes back the thing from get secret. So inside of the class, I can reference these private variables or properties or functions or whatever, but outside the class, I can't. So like, let's say we have like, let's start there. When a class does not declare a destructor, we'll automatically get an empty one. If you try to call get secret from outside the class, you'll get an error. We just saw that. To use private instance properties, you have to declare them as well. So you can't actually you can have instance properties for that instance, but you have to define them above. And I'm not sure I made that very clear up top here, but like here, the speed is connected to the instance itself being declared above. I think that's how it works. Yeah, so use private instance properties. You must declare them. Regular properties can be created by just assigning to them, but private properties must be declared in the class declaration to be available at all. This class implements an application or appliance for getting a random whole number given a maximum number. It has only one public property, get number. All right, so you're going to pass in. So I'd say like my rando or whatever equals new random source, and the constructor takes one thing, which is a number. So I can pass in 5. Now this 5 itself is going to be scoped. Let's see, I guess I have to console log this or something. So let's say console.log my rando.get number. So I can call get number. I could not call max because it's a private instance property. So it's not a method, it's a property. But so I can't do like max like this and expect to get anything back. Yeah, so max must be declared in an enclosing class. So it's saying, hey, this doesn't exist. But I can use get number like that. So I can pass in something that then is basically scoped to only that instance itself, and I can't access it outside. I have to only access it with functions or things like that, okay? All right, overriding derived properties. When you add a property to an object, whether it's present in the prototype or not, the property is added to the object itself. We've seen that before. You can just say like rabbit.name equals Chris, and it like updates the object with that. If there was already a property with the same name in the prototype, the property will no longer affect the object. It is now hidden behind the object's own property. So here we have rabbit.prototype.teeth equals small, and we can console log this, it says small. But if I say rabbit.teeth, long, sharp, and bloody, now when I console log it, it says long, sharp, and bloody, and I can no longer access the prototype.teeth. So let's use another example. Okay, let's say I come over here to student, and I want to create a new function here. We're going to say that this is called, imagine this, toString. All right. So I'm going to take whatever I passed in, and we're going to just take in, I don't know, we'll say this dot. Yeah, I guess I can just take in something. We can take in a string, and I could say string dot to uppercase. Oh man, so tricky. All right. So I'm going to pass this in, and this is what I'll return to you. Now, normally I have a toString method, right? So if I had a number like age, I could come in here and say I want to get the age dot toString, right? Now, normally this would work. I'm going to get the string of 25. This is a bad example. Let's say that it takes the string and returns like psych. All right, instead. Okay. So normally I could take student.age.toString. This works on the number itself, right? The actual thing I pass in. But I can also, now that I have this toString object here, I could pass in like, I don't know, whatever I want, like hi. And I expect to get hi, you know, or I guess this needs to be number. Let's try this again. Normally you have like a number you pass in toString. Here I've overwritten the prototype, so there's no way to access that. Now this is again another bad example because it's just a class, so you wouldn't have a toString in this anyhow. Let's do like length, all right? So normally if I say student.length, length like that, student.one dot, what do I have here? What's available to me? Since I clearly, I guess I would have like, dot, what's a good example of this? Maybe I should look at MDN to see what their example would be. This is going to have, what are other things that I could use off of this student? Object. Could I grab, maybe, I was trying to think of what I could even show. But basically what I'm showing is you can like override the prototype, which is what they're showing here, but I was trying to think of a better example off the top of my head, which clearly is failing. So let's look at their diagram and see if that helps. The following diagram sketches the situation after this code is run. The rabbit and object prototypes lie behind killer rabbit as a kind of backdrop, where the properties that are not found in the object itself could be looked up. So if you say, hey, get me rabbit.teeth, the first thing it's going to do, or I guess killer rabbit.teeth, the first thing it's going to do is look in the actual killer rabbit, which is here. It's going to say, does this have anything called teeth? Yes, it does. So it's going to give you that back first. It's only if it doesn't have something in the instance that it then goes to the parent, which in this case is rabbit. And it says, oh, actually, I've got something there. So if I didn't have teeth, it would then give me small. Now, if there happened to be on the mama object in JavaScript, something called teeth, then the same thing would happen, right? So it can also look up kind of the prototype inheritance. It can look up that and say, hey, I don't have anything here. Does it have anything here? Does it have anything here? Until finally you reach this one. This is always going to be the most outer scope. So overriding properties that exist in a prototype can be a useful thing to do. As the rabbit teeth example shows, overriding can be used to express exceptional properties in instances of more generic class and objects while letting non-exceptional objects take the standard value. Okay, so in other words, you can just use the standard one, but you can override them if you need to. So that's useful. So we could, for instance, instead of whatever that was, let's go back. I think I thought of an example that might make some more sense to whatever that was I was trying to do. Oh, come on. Okay, get cab name. So we've got this get secret thing. If I do get cap name, it passes back I ate all the plums. But let's say for student 1, I say, hey, actually for student 1, I want to redefine that. Even though it's on every object, I want to redefine get cap name. And I want this to be a function. And this function is just going to take in whatever, it'll take in this dot, I guess favorite. Yeah, it's not named correctly, but yeah, favorite food. And then, all right, why don't I just take in, yeah, I think this will work. Can I do this on, let's just pass back like Chris. All right, not worry about this. All I'm trying to show is that you can override this. So even though I have get cap name on the actual, like every single student always is going to have get cap name. For this particular student, I've overridden that function and said, I want it to be here. Now, if I get rid of this right here and we run it again, I get the original one. And that's what they're saying over here, is that normally you get whatever is defined first of all on the actual instance. If it's not found in the instance, then it looks up the chain. So for instance, here, if I call it, the first thing it's going to do is not immediately jump to kind of the mama student. It's going to first say, does student 1 have a function called get cap name just on its instance, like on it itself? It does. Okay, let's use that. Now, the next time I run it, if I get rid of this, it says, does student 1 have something called get cap name? It doesn't. Let's look at the prototype, at the actual like constructor, the mama here. Yeah, it does have one. Let's say this one didn't have one. So let's get rid of that. Now, if I run it, it should say it doesn't have it, right? There is no function called that. And it does that first by checking the local instance. Then it checks the kind of the mama object. Then it checks the object prototype itself, like the actual like final spot where all the objects kind of get their prototype or get their inheritance from. And it can't find get cap name there either, so it doesn't show anything, okay? Hopefully that makes sense. Overriding is also used to give standard function array prototypes to string method. Okay, this is probably one of the things I was thinking of. So array to prototype to string equals, it does not equal the same thing. Method, the basic object prototype. Okay, calling to string an array gives a similar result to calling join. Oh, I don't think I knew that somehow. To string call 1, 2. Okay, interesting. Okay, so we'll stop with maps and come back to that. We're about halfway through. Especially if you're not used to working with objects, it can be, or like classes and stuff, it can be kind of confusing. But it is an important concept to understand this whole object-oriented approach. And you can see the benefit, right? Like if you're creating an application that deals with student data, for instance, like a school thing, you want all students to have the same type of properties and that kind of thing. And when you create that student, like an instance of them, you want to be able to pass in their name, their age, their grade, their whatever, and all that is contained to their individual instance. But they still have access to all these functions that all the rest of the students have access to. So this gives you like a powerful way of packaging together ideas around a given topic or theme. Now, the other kind of style is functional programming, which is mostly what we've been doing, which is to have like clean functions that do exactly one thing. And if you need to know, for instance, like what the grade of the student is, instead of containing all of that on like this mama student class, instead, you just have these simple little functions that you pass in like an ID for the student. And the function handle saying, I'm going to look up that student's ID and use that to figure out their grade, and I'm going to pass that back. And a function does one thing. So they're kind of opposite ways of thinking. Object-oriented programming is kind of like the class does everything. It has everything connected. It has all you could ever need. All the buttons are right there. If you need to speed up, slow down, move left, move right, everything is connected to this class. Functional programming is more like saying you've got all these separate little tools in your tool shed, and when you need to do something, you pick up the precise tool that does only one thing, and you do that, and then you move on. So it can be kind of a cleaner way to work. That's typically how most JavaScript devs write code now, but that's not always been the case. And again, in most other languages, in many other languages, the kind of class object-oriented approach is the way to go. So it's important to know both of them. And again, JavaScript itself kind of has that as its underpinnings with this whole idea of prototypes. So hopefully it was helpful. There's a lot here, so we'll jump into it next time. But may you have the most blessed day you've had in a long time. I'll see you later. All right. Peace out.